All right, guys, we're going to come in here. We're going to find some solutions to cubics, and then we're going to turn them around and write them in factored form. And guess what? That is going to include the magical world of complex and imaginary numbers. So let's go ahead and get started. We're going to first start by taking x cubed plus 125, and we are going to factor it down. And we have to remember, first of all, that because we have a cube, we should be looking for 3x intercepts that are available to it. So let's take that x cubed plus 125 and plug it in here. So I go x cubed, cubed plus 125. And as I set that in here, I'm going to start to identify, hey, there's that cubic, but daggone, look at it. There's only one x-intercept. And that x-intercept that we're seeing right here is the value of -5. So what that tells us is we have one real x-intercept, which is x equals to -5, and we have two complex and what we always say crazy, imaginary. And remember that imaginary are just simply telling us that it's not, something is not occurring. In this case, it's telling us we have one real x-intercept and that the other two complex or the other two x-intercepts are not occurring in this case. So what we're going to do is we're going to take that x equals to -5 and we're going to find the factor for x equals -5, which is just simply x plus 5. And we are, in fact, going to divide that out of x cubed plus 125. So let's do that using the area model. That's my favorite method, hopefully yours. So I'm going to come over and say x plus 5. And then I'm going to go ahead and wrap that cubic all the way around. And I'm going to say x cubed plus 0x squared plus 0x plus 125. Remember, we have to account for the x squared and the x that are missing. And that's how we do it, by putting zeros right in front of them. Okay. Now, once we do that, we just start the division. I'm going to slide that x cubed into position. I'm going to write x squared up at the top. And then x squared times x is x cubed. X squared times 5 is now 5x squared. And remember, what I want to do is I want to change this intersection to addition. I want to circle these because they are going to combine to a 0x squared. This is 5x squared right there. So what combines to 5x squared to get 0x squared? -5x squared. Okay, once I've got that answered, I say, what do I multiply x by to get -5x squared? Well, that is -5 and an x. After we do that, I just bring down that -5 and that +5, and I multiply them. So -25x. And then once again, I said change this to an addition sign. I say, what do I add to -25x to get 0x? That's got to be 25x. Okay, and that's going to give us the value of 0. I need to find what I multiply x by in order to get that 25x, which is just simply 25. 25 times x is 25x. 25 times 5 is 125. Notice they're the same, so we are actually done at this point. So when we write this in factored form right now, we could write x plus 5 and then x squared minus 5x plus 25. However, that's not what we want to find, the x-intercepts. And then we want to write factored form with complex values in them. Okay. So what we're going to do now is we're going to come over here and we are going to take that x squared minus 5x plus 25, and I'm going to change it over to vertex form. And I'm going to do that by going over to Desmos, typing that in. Let's go x squared plus minus 5x plus 25 minus 5x plus 25. And I'm going to find the vertex, the minimum of this, which in this case is 2.5 and 18.75. So I come over to class pick and I say, okay, let's change this. X minus 2.5 squared, 18.75 plus 18.75, and I'm going to set it equal to 0. And I'm just going to solve, and this is where things get a little tricky. So I subtract off that 18.75. Okay, this cancels. I'm left with negative 18.75 equals to x minus 2.5 squared. I'm going to take the square root. And we know, guys, that when we take the square root of a negative, we cannot do that. But we can take the square root of 18.75. So let's do that. 18.75 comes out to 4.33. And what I'm going to write is 4.33. And I need to put a plus or minus in front of it because there was a square root. And I'm going to add an I, and that I is because there was a negative square root. And then I'm going to write x minus 2.5. Now at this point, I'm going to get rid of the minus 2.5. I'm going to add it over to the other side. Okay. I'm going to say that when I do that, I'm going to get 2.5 plus or minus 4.33i equals to x. So let's go ahead and go back to the original statement that was on there. It said, what are the x-intercepts? Well, the first x-intercept we found on the graph was x equals to -5, okay? The next two, which we said were complex and imaginary, are these guys right here, okay? 2.5 plus or minus 4.33i. So the first one we're going to say is x equals to 2.5 plus 4.33i. And the second one is x equals 2.5 minus 4.33i. Now, we have now solved for all of our x-intercepts, and we've written it in a form. In this case, it almost looks like factored form. But what we really need for factored form is x minus the root. So x with the root. So the first factor we said was x plus 5 because we use the opposite in the binomial. Well, we do that exact same thing with the other ones. We use the opposite of what's there. So I say x, this is a positive 2.5, I say minus 2.5. Positive 4.3, I put minus 4.33i. And then I write my other factor, which is x. I use the opposite of 2.5, which is right there, which is now minus 2.5. And I use the opposite of that minus 4.3, which is plus 4.33i. And now what we have it is all the way written down in factored form to its best. So we started by finding a factor by looking at the x-intercepts. We divided out that factor. And then we had to actually solve for the imaginary complex roots because two of them were going to be imaginary and complex. And then once we knew our x-intercepts, we brought it down and put it back into factored form, fully done. That's a long process. It is beautiful though, and a ton of fun to do. I hope y'all enjoyed it, and y'all have a great day. It's beautiful outside.